About the midpoint is the middle point. Literally, you can hear it in, oh, you can't see this, can you? So midpoint, middle point. And then we talked about the bisector is by, to, sect, divide, or cut. So divide it into two equal parts. Here, you've got M as the midpoint of AB. It divides it into two congruent segments. These little markings mean congruent. So if you see that on a shape or on a line, those little dashes, the notches, if they have the same amount of notches, it means congruent. And then you have the segment bisectors. This is a line CD, and it is bisecting AB at the midpoint. Again, those are congruent. You see it in the notches. Find RS. Okay, what do those little notches mean again, guys? Congruent. So what is the length of TS? 21.7. So how could I figure out what RS is going to be, Maddie? Yeah, add it up. And we get 43.4 is equal to RS. You can say RS without the marking over it because you're talking about the measure RS. Point C is the midpoint of segment BD. Find the length of segment BC. Okay. Tell me again what those notches mean? Congruent, which means that they're equal in measure, which means that BC should be, the measure of BC should be equal to the measure of CD, right? Because there's a midpoint in the middle. And so we are going to set these two things equal to each other. So we know BC is equal to CD. Therefore, BC is 3x minus 2. CD is 2x plus 3. We need to solve that equation. So we don't have anything to simplify, so we're going to isolate. We're going to add or subtract to get our variables on one side. Which one do you guys want to subtract? The 3x or the 2x? 2x, because it keeps it positive. Probably a good idea. And that will zero out. So we're left with x minus 2 is equal to 3. So x is equal to 5 if I add 2. Zach, what should I do? Yes, so 3 times 5 minus 2. Multiply first because of your order of operations, so 15 minus 2. So the measure of BC is equal to 13. Find the middle, right? If you find the middle or take the average, then you have the middle, the midpoint. But I'll give you a formula that you can use. I'm having a hard time writing today. And so the midpoint formula is this. I take my x values, add them up, and divide by 2. That's taking the average and finding the middle spot. For the y coordinate, I take the y values, y1 plus y2, add them up, divide by 2. So that's a coordinate point, is what that is. Find the midpoint. The endpoints of segment PR are P, negative 2, 5, and R, 4, 3. Find the coordinates of midpoint M. So we know that the midpoint is the average. So I'll say M is equal to. Now, you could just think in your head, what number is exactly halfway between negative 2 and 4? What would that be, guys? 1. Okay, so it should be 1. But if you aren't sure about it, you can always average. So negative 2 plus 4 divided by 2, the average, should be 1. Okay, the next one is 3 and 5. What's halfway between 3 and 5? 4. So it should be 4, but we can find it by doing the average. 5 plus 3 divided by 2. Okay, so I'm going to take my time on this one. So that would be negative 2 plus 4 is 2 divided by 2. And 5 plus 3 is 8 divided by 2. Do we get 1, 4? Yes. So the midpoint is 1, comma, 4, which you can get by just looking at the numbers and thinking what's exactly halfway. It's the exact same thing. The midpoint is 3, 4. And that's going to be equal to that averaging thing we talked about. So what is it? The endpoint is A. So 1 plus my other x value divided by 2. And then the y value should be 6 plus y divided by 2. So you can take these and set them equal to the midpoint. So I know that 3 should be equal to this, and 4 should be equal to that. So I can set up 2 equations. Again, you could do this just kind of thinking through it as well, doing what Ethan said, multiply by 2 your distance, or subtract that amount twice. So 3 would be equal to, oh, I'm in a highlighter. Three would be equal to 1 plus x divided by 2, and 4 would be equal to 6 plus y divided by 2. If you solve those equations, so multiply by 2 and then subtract 1, for that first one you get 5, and the next one you get 2, like we talked about. So your other endpoint, does it say C? C is 5, 2. Kind of equations you have to multiply first and then deal with the top part. You guys use Pythagorean theorem, so I'm just going to put or Pythagorean theorem. The distance formula just comes from Pythagorean theorem. So I'm going to give you the formula in a second, but if you have a grid, there's no reason why you have to use the distance formula. This will work just the same. So our Pythagorean theorem is this. That is what you guys used in addition to using your ruler, right? Okay, and it worked. So we were finding C yesterday. That's what we were solving for. Can't really see that. And so if I solve the Pythagorean theorem for C, then I get something that looks just a little bit different. So if I take the square root of both sides, then I get this. A squared plus b squared is the square root of that is equal to c. So all that's saying is the horizontal distance squared plus the vertical distance squared. If I take the square root of those things added together, then it should be the distance. What it looks like just a little bit. So if I change that to say the change in y squared plus the change in, oh, I did that backwards. Let's go back. Usually we say change in x first. Whew. Okay, change in x squared plus the change in y squared. That would be equal to your distance. So that's the exact same thing, a squared plus b squared, but written a little bit differently. The actual distance formula, so that's how I like to write it, but here's what you're going to see most of the time. And it's really long and it's kind of obnoxious, but here we go. Parentheses, x2 minus x1 squared plus y2 minus y1 squared, and you take the square root of all of that. All that's saying is horizontal distance squared plus the vertical distance squared. Take the square root of that after you add them together, and you get the distance. So So the triangle means change. So we're going to find the length of the segment whose endpoints is 2, 6 and negative 4, 14. You can plug in with distance formula. That's fine. And I'll do that. But you could also just see how far or how much they change. So what's the change from 2 to negative 4? There's 6 spaces between those, right?
Yep.
And how many spaces between 6 and 14? 8. So I know that my change in x is 6, and my change in y is 8. I'm going to do that with the subtraction, and you're going to see that I get the exact same thing, which is why it's not really necessary. Okay? But you can use it. So d, for the distance formula, is equal to, whatever you start with, you should probably start with on the x's and the y's. So I'll do 2 minus negative 4, the quantity squared, plus 6 minus 14, the quantity squared. Okay, and now we got to simplify it. What is 2 minus negative 4? 6. So 6 squared. What is 6 minus 14? Negative 8. So plus negative 8 squared. And then we simplify that. So are you seeing how it's the same thing? Negative 8 squared and 8 squared is the same. So you could have just used the change in y and change in x. So 36 plus 64, positive. If I add those two numbers up, what do I get? 100. So square root of 100?
10.
Which is 10. So the distance equals 10.